Assalamualaikum warahmatullahi wabarakatuh to Associate Professor Dr. Azyanti. My name is Aisha Ashikin binti Harun and I am supervised by Associate Professor Dr. Bulan bin Abdullah. My project is about industrial product design for manufacturing process efficiency and improvement at an aerospace company. My project is actually a collaboration with an aerospace manufacturing company to bring improvement in manufacturing process in their industry, So the main purpose is to lessen the human engagement, to reduce time and increase workers' productivity by increasing the efficiency and the quality of work. So the problem arises when in the production floor, there are inaccuracies result in certain routines due to the lack of standard guideline and the tool guides being reinforced. So the technicians will manually drill without proper jigs and templates, resulting in more inaccuracy and less precision and product. So, there are many unresolved issues and unused tools that cause inconvenience and inefficiency. So due to that, the routine are tedious and repetitive, which require recalibrating and remeasuring every time. So to improve productivity, a measure tool can set an improvement to the technician's work. Agility of product. From previous study, I focus on gathering information through interviews by interviewing experts. I make observation at the workplace, make an analysis through their technical notes and specifications that are given from Boeing and Airbus. And in this current study, most of the product design and proposed by me still do not exist in the manufacturing floor. Therefore, this project is being conducted to fill in any improvement that can be made for the manufacturing department. Objective for my project is to analyze repetitive issues in the production floor using qualitative methods and to study work processes and requirements on solving the issue in the production floor, and also to design solution for working routine improvement and efficiency in the production floor, such as testing tool and tolerance tool and many other improvement activities. Limitation in my project. First, in the area, the study will mostly include manufacturing, engineering department, and production department. And in specification, the area of study and the product is private, confidential. They cannot be displayed outside the organization. That will cause the organization is known. So the organization will benefit by not having to spend a lot of money on the new parts or material to redo. Apart from that, and in terms of economy, by increasing the work productivity, it will reduce the time activity so the workers can manage workload effectively, and also in the end improving sales and the company's recognition. For the social, all the issue resolved will gain the workers' confidence by using the method to do the work efficiently. So it will prioritize towards zero defect in their productivity. From my methodology, I use mostly qualitative methods, and the pictures are shown my activity during gathering while doing the project. By interviewing experts, I managed to make several meetings with the professional manufacturing engineer there. And this is the meeting for my theory and design to be discussed. And the second is the picture of me analyzing the technical notes and specification. And I do mock-up trial. After creating prototype, I do mock-up trial with the technicians. And lastly, I implement theory and design. This overall of my project output. I do at two areas. One is Airbus inboard flap, and another is at Boeing crew floor bulkhead. And the output that I produce is mostly design, a proposed improvement of the design and improvement at the blind hole counterbore on Airbus inboard flap. When I analyze the blind hole counterbore and inboard flap drilling requirements from work instruction and technical notes. So in the blind hole counterbore, there are outboard lower and inboard lower to be evaluated. See the picture of the inboard flap, and the drawing below is the outboard lower and inboard lower blind hole counterbore that I need to revise and improve their drill work. And then I make a cutter optimization. It is to reduce and step cutter. they used step cutter in the blind hole counterbore drilling. So at outboard lower, from 5 cutters, I managed to optimize it using 3 cutters by having a new cutter design. Before, there are many unnecessary step cutter being used. And after the optimization, the step drill cutter reduced time taken for step drilling routine in inboard flat counterbore hole. Inboard lower, from 8 step cutter being used, I managed to optimize 5 cutters only, including the new design. After the optimization, it will reduce time taken for step drill routine. A step drill bit for counterbore blind hole drilling. It is proposed as a one-step cutter instead of using reamer. Previously, the technicians will drill the hole one by one, step by step. For instance, in inboard lower, they use 8 cutters. And the 8 cutters, including reamers, cutter, and for the counterbore, they use only reamer. The design that I made is actually combining the final hole cutter bit and also the reamer. So the cutter, they can only have to use 2 cutter at one time. The step drill bit also includes as one of the cutter optimization. Why all the cutter need to be optimized? Why the step drill is being made is actually to reduce the time consumption on using too many steps, but in resulting just that one hole. Genius actually proved that we don't need that 8 cutters for just a hole, which it only require final hole and the counterbore hole. The final hole is G at G and the counterbore hole is at H. Combined as one step drill bit, which I designed for the outboard lower and inboard lower. So I actually improved their usage of the cutter. Then aside from their reducing time, they can help in drill in one hole. So this is the drawing for the outboard lower and inboard lower step drill bit. Guide, which is a stopper. This is created to improve the drill work by replacing the masking tape and manual adjust drilling. Before, the technician using masking tape as stopping guide. So it will result in accuracy. The manual drilling will mess up their work momentum by they need to drill it slowly to stop at their masking tape stopper and new collar type guide stopper, which the mock are looking like this. A proof when using this type of guide stopper, it will grip the drill bit and will not slip. So the drilling precision will go exactly like the one specified in the technical notes. Next is the depth setting block. So the idea and theory behind this setting block is that the setting block is acting like a gauge for the blind hole counterbore drilling on inboard flat. So to use it, I have the defect that I made the other day. These two are the depth setting block. So to use it, for example, this is the depth setting block, and this is, for example, the drill bit. So they don't have to recalibrate the drill bit using vernier caliper. For instance, they used to recalibrate all the 9 cutters by using vernier caliper one by one for every drill routine. So now when they have this block, for only at the blind hole counterbore drilling, they don't have to recalibrate, remeasure using vernier caliper for all 9 cutters. They only need to use this block, the cutter. They put the cutter in the block, and then they use the guide. This guide, they use the guide, and then they clamp it on the drill shank. And then after, they can just drill, and then for the next cutter, they put it inside, they stop it at the guide, and then they just drill. And the drill wood will look like this. the picture below. The block requires the measurement of the hole depth, the height of spoon, and the height of jig template. The hole depth is drawing this whole depth. Iron taken for measuring process using the vernier caliper takes about 30 minutes for the whole drilling process. So the technician will remeasure the depth and the height requirement using the vernier caliper for each cutter bit one by one. It is very time consuming to remeasure all the 5 to 8 drill cutter bits. So after implementing this, the time taken for measuring process shortened and taken for only 5 minutes. It reduced the time for drill routine. The technicians do not have to measure all the jig template, the spoon, the depth, and recalibrate the mark on the cutter every time they do drill work. So it actually saves a lot of time and increase their efficiency in work productivity. And this is the view of the hole depth, the jig template, and the spoon. These are the material selection for this product. There are a few selection, but the technicians, the workers, tend to like the acrylic clear and the resin clear material type due to it can be seen inside. And these two products actually being registered at the company to be as the official shop aid. The improvement that being made at the Boeing crew floor Buckley. I made shop aid improvisation and propose additional training material. And on the drill template for locating hole bracket, this one is actually a design. So previously there are many unused shop aid due to the inefficiency of usage and also lack of knowledge on how to use the shop aid for the technicians. So at this area for locating hole bracket, the shop aid has no border to guide. So the technicians do not use this shop aid as often because the shop aid will misguide them as the shop aid can be rotated 360 and they are confused which hole at which area will rotate 360. So they might confuse the hole is over there, 2 holes at the back, something like that. So the pilot hole often drill at the wrong placement. So after I propose to extend the border of the guide and have a leg as a stopping guide. So the shop aid will not be used in the wrong direction as it's locked and in its shape. This one is only a proposed design. Additional training material. They call as shop aid part illustration. So previously there are no shop aid PI on the board, and I propose this the old technicians are having problem by explaining one by one to the new contracts technician, the interns, and the new technicians from shop aid usage. So by having an aiding poster, it will help the leader to ease the process of telling how to use. So when shop aid is not being used due to the time consumption and the lack of explanation using the shop aid, the drilling and assembly parts will increase in accuracy of positioning and result. So by proposing this, the shop aid will be used by everyone to learn step by step by reading the poster. So the result of product will be more accurate due to the proper usage of shop aid available. And this poster has been registered as an official document to be put on the board. Is the detail of the shop aid. The first poster I made for filler shop aid. And the second one is the drill template plate shop aid. For a long-term improvement, it is recommended for the company to standardize all cutter for other general purpose tooling. The cutter that used on the shop floor must be the same from the supplier production, as the shank and the foot on different cutter does affect the process of standardizing jig and aiding tool. This is found when I interview the expert that are in tool and jig department. Can be wait. is that these two parts of the shop floor where this project is concerned, with recurring inefficiency issues that need to be resolved. So the analysis of the drill bit optimization, the step drill idea, the blind hole counter drilling needs, and a new drill bit stopper was done. For the FAJ, which is the crew for bulkhead bowing, a shop aid assists to improvement and design training materials were also created with the goal of improving the maintenance and crew efficiency and workflow by offering more practical and ergonomic alternatives. And that's all from me. Thank you very much, Dr. Azianti, for staying with me for this long.